Welcome to a video on solving special right triangles. The goals of this video are to determine the ratio of the sides of a 30-60-90 and a 45-45-90 right triangle, and then use those ratios to solve special right triangles. Let's start off by considering an equilateral triangle with each side of length 2. Remember, for an equilateral triangle, all of the angles would be equal to 60 degrees. Next, you'll notice that in red, I dropped a perpendicular bisector from one of the angles, forming two right triangles. Let's consider the triangle on the right. This angle here would now be 30 degrees, so we have a 30-60-90 right triangle. The hypotenuse would be 2, and this leg here would now have length 1, since this red segment bisected this side of the triangle. So now what we're going to do is take this right triangle here and find the length of this missing leg here. So we'll call this A, we'll call this side B, and we'll call this side C. So using the Pythagorean theorem, we'd have A squared plus 1 squared must equal 2 squared. So we have A squared plus 1 equals 4, A squared equals 3. Take the square root of both sides. We have A equals the square root of 3. So going back to our 30-60-90 right triangle, this leg has length 1, this leg here would have length square root 3, and the hypotenuse would have length 2. Now every 30-60-90 right triangle would be similar to this triangle here, and therefore the sides would be proportional. That also tells us that we can multiply or divide these three lengths by any constant, and it would also produce a 30-60-90 right triangle. And we can use that information to develop a general ratio among the three sides of any 30-60-90 right triangle. So for example, if we multiply each of these sides by x, it would maintain the same ratio. Notice the side opposite the 30-degree angle is equal to 1. 1 times x would be equal to x. Notice the side opposite the 60-degree angle is square root 3. Well, square root 3 times x would be x square root 3. And then lastly, the side opposite the 90-degree angle is equal to 2. 2 times x would be 2x. So what we've done now is develop the general ratio among the three sides of any 30-60-90 right triangle. And the reason that's helpful is if we can determine x, we can then determine the length of any of the other sides. Let's go ahead and give it a try. The first thing we need to recognize here is that we have a 30-60-90 right triangle, and the known side is opposite the 90-degree angle. So if we go over here to our ratios for any 30-60-90 right triangle, notice that the side opposite the 90-degree angle is equal to 2x. So for this triangle, 2x must equal 15, and that's our equation that we need to solve. So if we divide both sides by 2, we have x equals 15 halves, or 7.5. Let's go ahead and leave it as 15 halves. But now that we know x, we can determine the length of the side opposite the 30 and 60-degree angle as well. Notice that the side opposite the 30-degree angle is equal to x. So here's the 30-degree angle. The opposite side here would be equal to 15 halves. And notice the side opposite the 60-degree angle would be equal to x square root 3. So we'd have 15 halves times square root 3, or 15 square root 3 divided by 2. And now that triangle is solved. Let's go and take a look at one more. Again, the first thing we should recognize is that we have a 30-60-90 right triangle, and we also know the ratio among the three sides. On this problem, we're given the side that's opposite the 60-degree angle. So if we look at our ratios, notice the side opposite 60 degrees is equal to x square root 3. So now we have x square root 3 must equal 6. We can solve this for x and then find the length of the two missing sides. So we'll divide by square root 3. So we have x equals 6 divided by square root 3. Let's go ahead and rationalize this. Looks like we're going to have 6 square root 3 divided by 3, so x is equal to 2 square root 3. Now going back up to our ratios, x is the length of the side opposite the 30-degree angle. So here's the 30-degree angle. The opposite side here must equal 2 square root 3. And the side opposite 90-degree angle must equal 2 times x, or 2 times 2 square root 3, and that would be 4 square root 3. And now that triangle is solved as well. Now let's go ahead and apply the same principle to a 45, 45, 90 right triangle. What we're going to do now is start with a 1 by 1 square, so we know each angle is equal to 90 degrees. In red here we have the diagonal, which will bisect these two angles. Therefore we have a right triangle here where one angle is 90 degrees and the other two would be 45 degrees. We should also notice that the two legs of the right triangle are equal to 1, so now we can use the Pythagorean theorem again to determine the length of the hypotenuse. So we'll call these two legs A and B. The hypotenuse would be C. So we're going to have 1 squared plus 1 squared must equal C squared. So we have 2 equals C squared. So we have C equals square root 2. So now we know the relationship among the three sides of any 45, 45, 90 right triangle. Any other 45, 45, 90 right triangle would be similar to this, which means it would also be proportional. Meaning we can multiply or divide these three lengths by any constant and it would produce a similar 45, 45, 90 triangle. Let's go ahead and multiply each side by x. So notice the two sides opposite the 45-degree angles would be 1 times x, or just x. And for the hypotenuse, we'd have x times the square root of 2. We'll use this general ratio to help solve any 45, 45, 90 right triangle. Let's go ahead and try. Again, notice in the upper right-hand corner we have our ratios, and we're given a 45, 45, 90 right triangle. Notice that we're given the hypotenuse, or the side that is opposite the right angle. So going over to our ratios, that means 10 must be equal to x square root 2. Let's go ahead and set that up. X square root 2 must equal 10. We'll go ahead and solve this for x. Let's rationalize. So we have 10 square root 2 all over 2. X is equal to 5 square root 2. Notice that the two sides opposite the 45-degree angles are both equal to x, so now we've solved the triangle. This is 5 square root 2 units, and so is this. And let's go ahead and try one more. So again, we need to recognize that this is a 45, 45, 90 right triangle, and the known side is opposite the 45-degree angle. And notice that our ratios tell us that x is equal to the side opposite the 45-degree angle. So we don't have much of an equation here. X is equal to 2 square root 10. Which means the other side opposite the 45-degree angle is also 2 square root 10. And then the hypotenuse, or the side opposite the 90-degree angle, would be equal to x times square root 2, or 2 square root 10 times square root 2. So if we call this side C, we'd have C equals 2 square root 10 times square root 2. Well, that's going to give us 2 times the square root of 20. Of course, this simplifies. 20 is the same as 4 times 5, and 4 is a perfect square. So this simplifies to 2. We already have a 2 here, so that would give us 4 square root 5. So this missing side here would be 4 square root 5. And now that triangle is solved. So knowing the ratios for the 30, 60, 90 and the 45, 45, 90 right triangles can be helpful when you're trying to solve these types of special right triangles. I hope you found this helpful. Thank you for watching.